Have you ever looked up at the night sky and wondered what lies beyond the stars we can see, beyond the familiar planets and constellations? There are vast, uncharted territories, the most remote regions of space, holding secrets that could rewrite our understanding of everything. Today, we're embarking on an epic journey to the edge of the known universe, and then diving into one of its greatest enigmas, the hunt for dark matter. Let's start by traveling billions of light years away. Imagine a place called the Boat's Void. It's not a place you'd want to get lost in. Discovered in 1981, this colossal, almost spherical region of space is nearly 330 million light-years in diameter. To put that in perspective, our own Milky Way galaxy is just 100,000 light-years across. What makes the Boat's Void so eerie is its emptiness. Based on the average distribution of galaxies in the universe, a space this size should contain thousands of them. Instead, astronomers have only found about 60. It's like finding a major city with only a handful of houses. This cosmic desert challenges our models of large-scale structure formation. How could such a massive void form? Was it the result of smaller voids merging over billions of years, like bubbles in a foam? Or is there another, unknown cosmic process at play? The Boat's Void is a silent testament to the vast, empty spaces that dominate our universe, reminding us that what we see is just a tiny fraction of what's out there. Now, let's push even further, to the very edge of observability. We're heading towards the cosmic microwave background, or CMB. This isn't a place, but rather a faint glow of light that fills the entire universe. It's the afterglow of the Big Bang, the oldest light we can detect, emitted when the universe was just 380,000 years old. Before this time, the universe was a hot, dense soup of particles, so dense that light couldn't travel freely. The CMB is essentially a baby picture of our universe. By studying its tiny temperature fluctuations, scientists can learn about the initial conditions that led to the formation of galaxies, stars, and ultimately us. Instruments like the Planck satellite have mapped this ancient light with incredible precision, revealing a snapshot of the seeds from which all cosmic structures grew. It's the ultimate archaeological dig, taking us back 13.8 billion years to the dawn of time. These remote regions are fascinating, but they also point to a profound mystery. When we observe how galaxies rotate and how they cluster together, we find a problem. The gravity from all the visible matter stars, gas, and dust isn't nearly enough to hold them together. Galaxies are spinning so fast they should fly apart. It's as if an invisible hand is providing the extra gravitational glue. This invisible substance is what we call dark matter. We know it's there because of its gravitational effects, but we can't see it, touch it, or detect it with any of our current instruments. It doesn't emit, absorb, or reflect any light, hence the name dark. The shocking part, scientists estimate that dark matter makes up about 27% of the universe. The normal matter that makes up everything we've ever seen or known. That's only 5%. We are the cosmic minority, living in a universe dominated by a substance we don't understand. So, the hunt is on. How do you find something that's invisible? Scientists are using a three-pronged approach. First, they're trying to create it. At particle accelerators, like the Large Hadron Collider at CERN, they smash particles together at nearly the speed of light, hoping to produce a dark matter particle in the debris. If new, unexpected particles appear that fit the profile, heavy, neutral, and weakly interacting, it could be our first direct glimpse of dark matter. So far, no luck, but the search continues with even more powerful collisions. The second method is direct detection. Deep underground, in laboratories shielded from cosmic radiation, scientists have built incredibly sensitive detectors. These experiments are essentially waiting for a dark matter particle, a WIMP, or weakly interacting massive particle, to bump into an atomic nucleus. The Lux Zeppelin, or LZ, experiment in South Dakota is a prime example. It uses a massive tank of liquid xenon, hoping to see a tiny flash of light or an electrical signal caused by one of these rare collisions. It's like listening for a single pin drop in a hurricane, requiring immense patience and precision. Finally, there's indirect detection. If dark matter particles are their own antiparticles, they should annihilate each other when they meet, producing a shower of detectable particles like gamma rays or neutrinos. Telescopes like the Fermi Gamma Ray Space Telescope scan the skies, particularly the dense centers of galaxies where dark matter is thought to be concentrated, looking for this telltale annihilation signal. A mysterious excess of gamma rays from the center of our own Milky Way was a tantalizing clue, though scientists are still debating if it is truly the signature of dark matter or just an undiscovered population of pulsars. Are we getting closer? Every null result from these experiments helps us narrow down the possibilities. It tells us what dark matter isn't, refining our search and pushing theoretical physicists to come up with new ideas. Perhaps dark matter isn't a WIMP at all. Maybe it's a much lighter particle called an axion. Or perhaps our understanding of gravity itself needs a revision. This is how science works. Each dead end brings us one step closer to the truth. From the silent emptiness of the boat's void to the ancient light of the CMB, the universe is constantly challenging us. The search for dark matter is more than just a quest for a missing particle. It's a quest for a fundamental understanding of our cosmic home. It represents one of the biggest gaps in our knowledge, a vast, dark ocean of which we have only explored the shoreline. But humanity has always been driven to explore the unknown, to map the void, and to shed light on the darkness. The answer is out there, waiting in the silent depths of space or in the heart of an atom, and finding it will forever change our place in the cosmos. Thank you so much for joining me on this incredible journey to the frontiers of science. If you found this as fascinating as I do, don't forget to hit that like button, subscribe to the channel, and ring the bell so you won't miss our next deep dive into the mysteries of the universe. See you next time.